Hi everyone. Today we are going to continue working with trigonometric equations and section 7.5. New things in section 7.5 we are going to cover are how to use identities when we solve trigonometric equations. And for example, we are using identity to solve next trigonometric equation, sine of 2 theta minus cosine of theta equals 0. So how to use identities? Well, we do know that sine of 2 theta equals to 2 sine of theta by cosine of theta. And we copy the rest of the equation. Pay attention to where are we looking for a solution here. I'm asking you to find all solutions on the interval from negative infinity to positive infinity. Please pay attention, because sometimes it's going to be just from 0 to 2 pi, and sometimes it's going to be just a different interval. Here we are looking for all the solutions. So how are we going to solve it after we use the identity of double angle? Well, we are going to take outside of parentheses cosine. That's what I'm going to do, cosine of theta outside of parentheses, and in parentheses 2 sine of theta minus 1 equals to 0. We do know when two factors multiplied and give us 0, either the first one equals to 0 or the second one equals to 0. So we are going to get two separate equations, which we are going to solve separately. So the first equation, cosine of theta equals 0. When cosine of theta equals 0, well, we do know that cosine of theta equals 0 at angles theta, for example, equals pi over 2, right? And also negative pi over 2, which is actually like what, 3 pi over 2. And so on, right? How do we write it down in general? Well, we see that if you draw a unit circle, right? Unit circle, cosine equals 0, which is x equals 0, is going to sit over here and over here. What we can do, we can write down that theta equals pi over 2, and then plus pi n. Usually we do add 2 pi, right? But here, because actually you add pi and get another solution, and then you add pi and get another solution, that's going to be just pi n. What is n? Well, n is going to be integer. Integer means that it can be what? Minus 1, minus 2, minus 3, or plus 1, plus 2, plus 3. It can be also 0. You know, it's all integer numbers. So we're done with the first one, but I'm going to label this theta 1, right? Because that's just the first solution. We're going to move to the second one. And the second one is cos 2, oh, sorry, give me a second, guys. Started copying cosine again. The second one is 2 sine of theta minus 1 equals to 0, which is going to give us what? Sine of theta equals 1 over 2, right? I moved 1 to the right side divided by 2. Well, what we are going to have, unfortunately, is whenever I'm touching whiteboard, it gives me a little marks on it, which I don't want to have. So I'm going to draw a unit circle here again, and you are going to see that on a unit circle, sine, you remember sine is y, right, equals 1/2, and y equals 1/2 somewhere here, is going to produce two angles, right? The one is going to be like 30 degrees, which is actually what, pi over 6, and one is going to be pi minus 30, which is 150 degrees, 150 degrees, or it's also like 5 pi over 6. So I'm going to write them down separate. I'm going to write down theta 2 equals pi over 6, and theta 3 equals 5 pi over 6. Except, remember in section 7.4, I was telling this, except the end points, like points here, 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 and here. All other values of sine are going to produce two angles. Same for cosine, right? Exceptions are going to be where cosine and sine equals to 0, or 1 or minus 1. There's going to be like exceptions. So what we have here, guys, these are only two solutions which exist on interval from 0 to 2 pi, but we are going to add 2 pi k, and over here 2 pi k, and going to say that k is integer. Why do we add 2 pi here? Well, because next solution is going to happen when you have like pi over 6 plus 2 pi, right? You make a full circle and go back. There are no other solutions. Here we were adding only pi just because solutions were kind of coming like here and here. Actually, you can write down as two solutions like pi over 2 plus 2 pi k, right? And 3 pi over 2 plus 2 pi k. Just a simpler way to write it down. Now I'm going to combine all three solutions and give the final answer. So theta 1 equals pi over 2 plus pi. I'm going to use k instead of n, just like to have k everywhere, okay? Theta 2 equals pi over 6 plus 2 pi k, and theta 3 equals 5 pi over 6 plus 2 pi k, and k here is integer. Now, that was not a question, but I want to kind of point that if somebody is asking us to find solution on interval from 0 to pi, let me use a different color to kind of separate it. Sorry. Somebody is asking us, what are solutions from 0 to pi? What are possible solutions on interval from 0 to pi? Well, we do know that there are going to be this solution, this, and there are going to be two solutions from pi over 2, right? Because one sits here and one sits here. So if you want to list all those solutions, it's pi over 2, 3 pi over 2. If you add over here k equals, if you put over here k equals 1, you are going to have 3 pi over 2. It fits into the interval, right? Two more solutions is pi over 6 and 5 pi over 6. I don't really care if you put them in order or not in order, so just put it anyway. That's how we use identities and how we solve and have multiple solutions. Remember, trigonometric equations usually are going to have multiple solutions, either infinitely many like over here, or like 4 if you use a certain interval. Okay, now I want to consider another example where we have a multiple angles or multiples of angles. Okay, I'm going to move to a different page. Just kind of, okay, let me see. And consider my second example. I'm going to use a blue color, okay? Example 2. What is multiple of angle? Multiple of an angle. Well, example of equation like this is 2 sine of 3 theta minus 1 equals to 0. You see here, the angle is not just theta, but it's 3 theta. How different is going to be a solution? We kind of touched this in 7.4, but I want to just do it one more time because usually people don't understand it very well. You solve it as usual. So you move 1 to the right side, divide by 2. So you are going to get something like this. Sine of 3 theta equals 1 over 2. Well, draw a unit circle. And we are going to see that on a unit circle, we already have this y equals 1 over 2. Y equals 1 over 2 is going to happen over here and going to produce two angles, right? Pi over 6 and 5 pi over 6. I'm going to write them down as two different solutions, 3 theta 1. Here, my angle over here, pi over 6, it's actually not just theta, it's argument of sine, and in this case, it's 3 theta. So I'm going to write down 3 theta 1 equals pi over 6 plus 2 pi k. And my second angle is 5 pi over 6. So I'm going to write down 3 theta 2 is 5 pi over 6 plus 2 pi k. Well, because we are not searching for 3 theta, but we are searching for theta, I'm going to divide everything by 3. So my first equation is going to be theta 1 equals pi. And if I divide pi over 6 by 3, I'm going to have pi over 18. 2 pi k over 3, right? I cannot cancel anything here, so I'm going to keep it as it is. Theta 2, 5 pi over 18, because 6 and 3 are going to combine into 18, plus 2 pi k over 3. So if somebody is asking for general solution on interval from negative infinity to positive infinity, that's going to be a general solution. You see, the difference is that you need to do a little bit more math to calculate actually theta. Now, if somebody is asking you to find a solution on interval from, so this is solution on interval negative infinity to positive infinity. Forgot to mention that k is integer. right? What if somebody is asking us to find solution in an interval from 0 to 2 pi? How we are going to kind of give our solution? Well, guys, here we need to obtain all theta 1, which are going to sit from 0 to 2 pi. How are we going to do it? Well, we are going to start with theta 1 and set up k equals to 0. Theta 1 is going to be what? Pi over 18. Does it sit to the interval? Yes, it sits in the interval. K equals 1. I'm going to plug it in over here and get theta 1 equals pi over 18 plus, if I put 1 over here, I'm going to get 2 pi over 3. Is it still between 0 and 2 pi? Yeah, it is. We can combine it together and see that the answer is still between 0 and 2 pi. So what is missing over here is what? If you multiply 3 by 6, you get 18, right? So we have pi plus, well, 12 pi multiplied by 6, numerator and denominator divided over 18, and we have 13 pi over 18. It's still less than 2 pi, so this is going to be one of the solutions. Let's try k equals 2. Theta 1 is going to be pi over 18 plus, if I put k equals 2 into my formula to here, I'm going to have 4 pi over 3. 4 pi over 3. Is it still going to be within our interval from 0 to 2 pi? Well, check it. Again, multiply by 6 this fraction to kind of bring it to common denominator. So we're going to have 24 pi and denominator is over 18. So it's 25 pi over 18. Is it still less than 2 pi? Yes, guys. It's still less than 2 pi. Why? Because if you multiply 2 pi by 18, if you bring it to common denominator, you are going to have 36 pi over 18, right? 2 pi, it's actually 36 pi over 18, which is kind of greater than 25. Now let's try k equals 3. And theta 1 is going to be pi over 18 plus, and if I plug in 3 here, 3 and 3 are going to cancel and I get 2 pi. I do see that this number is obviously going to be greater than 2 pi. How do I know this? Well, just because it's 2 pi plus something else, right? It's greater than 2 pi. So I'm going to stop doing my solutions from this point. This is already does not match. So what I'm going to have, I'm going to have 3 solutions from this first formula, and they are going to be pi over 18, 13 pi over 18, and 25 pi over 18. I wanted to write down 36. Okay. 25 pi over 18. Now I'm going to move to my second formula. In my second formula, I'm going to set up k equals 0 and get theta 2 equals 5 pi over 18, right? And k equals 1, theta 2 equals 5 pi over 18. We already know that it's going to be like what, 2 pi over 3, which is going to give us, if we multiply by 6, 5 pi by 6, 12 pi and over 18. Well, we do have like 17 pi over 18. It's less than pi and of course less than 2 pi, so it fits to us. K equals 2 is going to produce 5 pi over 18 plus 4 pi over 3, right? If I plug in 2 here, I'm going to get 4 pi over 3, which is going to produce 5 pi plus 24 again pi over 18. I'm multiplying by 6 numerator and denominator of my fraction. Give me a second, guys. I have extra lines here, which I don't want to have actually. So what do we have? 5 plus 24 is going to produce 29 pi over 18. Is it still less than 36 pi over 18, which is 2 pi? Yeah, it's still less than 36 pi over 18, which is actually 2 pi. So it fits to us. How about k equals 3? Theta 2 is going to be 5 pi over 18 plus what? If you plug in 3 here, you're going to get 2 pi. Obviously, this is greater than 2 pi, so we are going to kind of quit working with new case after this point. So here we are going to have what, 3 more solutions, and they are going to be 5 pi over 18, then 17 pi over 18, and 29 pi over 18. Hopefully. So what is going to be my total answer? If somebody is asking me to find solution in interval, the sum of these 2 answers, so these 2 together, we can combine them and total answer is going to have 6 different values for theta. Okay. Well, I'm going to do one more example because again, this topic is fairly complicated, and sometimes people just get very confused. So I'm moving to next page, and I'm going to consider a different function, tangent function. So let me change my color. I'm going to do dark green. So example number 3. So equation is going to look like this: square root of 3 tangent of theta over 2. You see, before I multiplied theta by 3. Now I'm going to divide it by 2. Extra line, which I don't need, okay. So square root of 3 tangent of theta over 2 equals to 1. Again, first we isolate tangent, and we are going to get, oh, sorry, I started writing with my eraser, and we are going to have tangent of theta over 2 equals 1 over square root of 3. Unit circle, right? We are going to see, okay, tangent of what angle is square root of 3, 1 over square root of 3. Well, we do remember that this is pi over 6. The angle is pi over 6, right? And we remember that tangent is periodic with period pi. So we can write down that theta over 2, which is argument of tangent, is equal pi over 6 plus pi k. Again, because period here is just pi, we're not adding 2 pi k, we're adding just pi k. And k, of course, is going to be integer. Okay, so you got the difference. Well, how do I know it's 5 or 6? Again, it's a table value. Remember, we were doing the table tangents for tangents, and 5 or 6, tangent of 5 or 6 is 1 over square root of 3. If you had negative 5 or 6, it would be negative 1 over square root of 3, but we just have one value. Now, what I'm going to do next, I'm going to multiply all equation by 2, because I'll need just theta. I don't need theta over 2. So I'm multiplying by 2, and I'm getting pi over 3. If I multiply pi over 6 by 2, 2 and 6 are going to cancel. 2 and 6 are going to cancel and give me 3, right? And we're going to have 2 pi k here. K is integer. That's my final solution on interval from negative infinity to positive infinity. If somebody is asking me to find solution on interval from 0 to 2 pi, how I'm going to look for it? Well, I just need to find all possible values of theta which fit into this interval. Here it's going to be very easy. Theta is going to be 5 over 3, and this is for k equals 0, right? And for k equals 1, we are going to have pi over 3 plus 2 pi, which is already like outside of the interval. So we're going to say, okay, let me read it first and write it down the reason why it's not okay. So this is going to be greater than 2 pi, so it doesn't work for us. If somebody gives us interval from 0 to 2 pi, it's going to be outside of the interval, so we have just one solution, only one solution here. Or general solution is going to look like this. Well, that's it. So I think you can just do the homework on this section. And if you're still kind of struggling, try to watch one more time my video about 7.4, because I consider several of problems like this in 7.4 too. Okay, well, I think that's going to be it. And we are going to kind of finish this lecture at this point.